Hello, everyone, and welcome to another episode of Generative Geek. Today, we are going to discuss OpenRouter. OpenRouter is a very innovative platform that I have recently found, and it provides unified access to multiple large language models through a standardized API. And what I really like about this is that if you go to the platform and you create yourself a login, you will have to first go to openrouter.ai, create yourself a login. You can see all the models that it supports, and the best thing is it will give you all the information about the model. Let's just say I want to look at Gemini, right? So let's just say some more popular models first. So Gemini Flash 1.5, it will tell you what are the number one, what are the few use cases for which people are using these models. Then you will see what is the cost. Like it charges 25 cents for a million tokens. So you will see all of that. You can see who are the various providers who are offering this. So right now only Google is offering this. There's a ton of information that this site provides. Then you have rankings across category. You can see, hey, you know what, if you want something for your marketing thing, you have various marketing projects around content writing and stuff, which are the best models right now, which have a lot of usage in terms of people using them. And you will see that, okay, maybe top today we see Claude 3 Haiku is the one which most of the users have been using. You can see it which are the ones that are trending right now, and you will see very quickly that GPT-4o mini, which was recently announced, like a couple of days back, is the most trending, right? So I won't be surprised if this becomes one of the top model, very, because look at the cost, right? You go here, you look at the cost. The cost is like 15 cents for a million tokens. Even an open source model like llama 3 dolphin llama 3 70 billion parameter model has like a 59-cent cost, right? So this model is even more costlier than, let's say, the GPT-4o mini. Today what we are going to do is, what I'll suggest is, first, as a prerequisite, go and get yourself a login for openrouter.ai. And once you have a login, maybe add a couple of dollars, $5 on this to this system, so that you can use a lot of you can experiment with it, right? So if you look at my usage, I have been using it since last couple of days. And look at the cost, right? So each of my these costs, like these test costs, is like hardly anything, right? And I've tried various models. So today's video is largely about what we'll do is, and once you have done this, you will be required to go get yourself a key. So maybe get yourself a key. You can even set how much how many dollars you want that key to consume, so that there is no sort of an abuse in case that key gets leaked outside. The way to look at it is that, once you have all of this, this is what we are going to do. We are going to have like a prompt, and this prompt is then going to be sent to open router, and we are going to connect open router with three models, right? And these can be any three models, right? If you go here and you say, hey, you know what, go to open router, you want to find the best models. There's a lot of stuff, like you want text to text models or text and image to text models, right? So if, let's say, text and image to text, what is the context with length you are looking at, right? So let's say if I'm looking at 64K context length, and what is the pricing, is there a series, is there a category you have in mind, right? If, let's just say, marketing SEO is my category, I'll select that, and then basis that, a lot of models will keep getting filtered out. And you see right now only OpenAI and Anthropic and Google are there. No open source model has made it, right? So but if you relax this, maybe you will start seeing a few open source models also show up, right? So no, not with this, because maybe this is text to text, and we are looking for very large context windows here. But you can see, hey, what supported, does it support tools and all of that, right? So really interesting platform. I'll suggest that you look at it, and they offer cost to cost basis, is what my understanding is. There's no markup they add on it. So go through it. You can go through various models, like what they are good with, what are the various use cases people are using it for. And these use cases then become food for thought, right? Maybe why should I not build something around translation? Why can I do something more around programming with these, right? So and they have another very interesting flavor feature, which is called flavor of the week, right? So flavor of the week is more like a single endpoint, but they keep rotating the models behind, right? So right now they have llama 3's Theno 8 billion parameter. That's the model. If you make a call to this model, this is the underlying model, but they keep changing it every week. So next week maybe some other model will be used, right? So, or next month probably, if not week, right? So but this is the router model that rotates its underlying model weekly, right? So it rotates underlying model weekly. The model ID is still the same, but they will start pointing to a different one. And while they have a lot of code around how you should make calls, what I'm going to do today is we are going to make use of LangChain, right? And we're going to write a custom class in LangChain that will then be able to use OpenRouter, right? So I'll show you all of that. What we are going to do is take the prompt, send it to OpenRouter, then send it to three models. I'm picking OpenAI, Mythomax, and Claude. Mythomax, if you are not sure, uh, there are various Mythomax models available. I'm going to make use of one of these. Then we'll compare results. We'll compare how many tokens were required, input and output, what was the cost, what was the latency, what was the response to the prompt. In terms of tokens, the way I'm going to do it is we are going to make use of tick token with a certain encoding. Some of these models might not honor that encoding, but you will get the sense of how to think about these problems, right? I'm not giving you the solution here. I'm basically giving you a way of how to think about such problems. That's my goal, right? So without further ado, let's get started. So I have my collab notebook open, and with this, now the use case we are going to build is this. So first, let's get started. Let's install all the necessary libraries that we'll need. So I'm installing LangChain and LangChain underscore community. I'll also install OpenAI, right? So first step is go out and get yourself a collab notebook, give it a decent name, and then mine is called OpenRouter LangChain tutorial demo. Provide The first step is go out and start installing all the necessary libraries. So I'm installing langchain underscore community. It will take a little while, but once this is done, the way we'll do it is I'm going to create a class called chat open router, which will be a subclass of chat open AI. So it'll give you a good sense of how you can take chat open AI and maybe make subclasses of it. What you should also do is once you have your login created, go to keys, login on open router created, go to keys and get yourself a key. And once you have that key, come back to Google Colab and give this key, right? So my key is called open router underscore API underscore key. Give this key access to the notebook, right? So otherwise this key won't be the notebook won't be able to read the key even if the key exists, right? So give yourself this access. Open router has, like I mentioned earlier, it's a pay as you go kind of a model. So whatever calls you make, they will be available here, so you can see, you can audit all of that. Now that my libraries are all installed, I'm going to get started with the imports, right? So the first thing I'm going to do is langchain underscore community. From langchain underscore community dot chat underscore models, I'm going to import chat openai, right? So chat openai, I'm going to import os, I'm going to import openai, and we'll also need tick token. Plus we'll also need optional from typing, right? So I have my oops, from typing import optional, right? So I have my imports done. Next, I'm going to build a class called chat open router, and so we'll define a class. We'll say class chat open router. This will be the class that we'll use to make calls, and it will be a subclass of chat open AI, right? So let me first define the constructor. It will be def init underscore, and then first argument, as you always know, is self. Then we have model underscore name. It'll be a string. OpenAI underscore API underscore key. Again, optional string. Uh, Next, what we'll do is we'll have OpenAI underscore API underscore base. This will also be a string, and we'll give it a value https colon slash slash open router dot AI slash API slash v1. And where am I getting this from? This endpoint. If you go here and you maybe go to any model, right? So I go to Mistral Nemo. Um, and if you look at the if you go to OpenRouter, I'm just trying to find where they have code listed. They have a lot of code also listed. So Dolphin 3 is 7 billion. No, OpenRouter. Just give me like a second, trying to see where is the, yeah. So if you look at this, right, so this is what the base till v1, right, so this is the base url. After that is basically dependent on whether you want the completions, you want translations, you want transcriptions, but this thing mostly remains the same, right? So this becomes our base. Now this is very specific, this is a completions thing. I am not going up till that point, I am just going till here, right? So look at it, base url, this is where I'm going till, right? So and this is exactly what we are trying to do, like, very similar to what we are trying to do. They have like, they are making use of OpenAI library, I'm going to make use of LangChain library. That's the only difference, right? So open router v1. Next, what we want to do is we want to pass in all the keyword arguments that optionally come. So keywords, your signature of the constructor is now defined. Now let's go out and get started with actually building the function, right? So we'll say, we'll first try to get the API from various sources. So, and the way we are doing it is we have our API in Google Colab. That's what I was showing you earlier. So our API is in the open router underscore API underscore key. That's the variable name. You should use whatever is the variable name that you have in your Colab, or wherever you have your code setting, right? So, and then I'm going to say open router underscore API underscore key is equal to user data dot get open router API key. The suggestion is looking okay. If OpenAI API key is none, no, I don't want to use this right now. Though it's very similar to what I want to do. I want to basically define API key here itself, right? So I'm going to say API underscore key is equal to OpenAI underscore API underscore key. In case if it is getting passed here, this is the first parameter. Or if it is not getting passed, then I want to use open router API key. Yeah? I hope this is clear till now. Next, what we'll do is, our API key is set, but we should still have some sort of an error handling. If not API key, then what we'll do is, we'll say from, actually, you know what, this is not required, because our API key, if it is not found in the init and if it is not found by Collab, then there is no way we have the API key, right? So API key is now set, and we are going to now pass in this to the base super class. um, this is what we are going to do. Super underscore init model underscore name is model name, OpenAI API key is API key, OpenAI API base is OpenAI API base. Yes. So this is basically how the chat OpenAI constructor looks like, and I'm just passing it whatever is required, right? So that it's all available. Because we are basically going to make use of the same class attributes. Now I'm going to say self dot OpenAI underscore API underscore base. It has to be a string OpenAI underscore API underscore base. Yeah, I'm setting the class level attributes now. Self dot OpenAI underscore API underscore key. Again, a string is equal to API underscore key. Model underscore name is model underscore name. Yeah. Next, we'll just quickly configure the OpenAI library, and we'll say OpenAI dot API base is OpenAI API base. I don't even need this. And this is API, no, it's OpenAI dot API underscore key is OpenAI, not OpenAI, it should be API underscore key. Yeah. So with this, my class is now ready. My chat open router class is ready. I hope you understood what we did. We first defined a constructor. Our constructor takes the model name, OpenAI key, and we had to hard coding what the base is, right? And then we try to fetch the key, and we set the key, and we pass all of this to the super class, right? Which is the chat OpenAI class, right? So I'm passing all of that to as the constructor, right? So So the only role of chat open router, if you look at it, is to basically just set this and set the key of open router API key, because all the other endpoints, all the model name, everything is going to be same, right? That's the beauty of the way they have built their APIs. So they are not like completely different APIs. You can, and therefore we can use this very open AI library, right? Now let's get to the point where we'll first make a try call, right? So I'm going to say langchain underscore core dot prompts import chat prompt template. So I'm going to bring in a chat prompt template, and I'm going to say, hey, my LLM is chat open router, and the model name, we can have any model name here. Let's pick any model for that matter. Maybe we'll go to open router, we'll say, hey, browse, give me any free router, right? So give me any free model. Google Gemma 29B is free. I'm just going to take this. So if you look at it, there's no cost. The latency is also very low, 690 milliseconds roughly. Chat open router, and we are going to give it the name, right? So this becomes this is where I'm basically setting the model name, right? So this is the part which I'm setting here, if you look at the class. And next I'm going to say the prompt is equal to chat prompt template dot from template, not from messages. We'll define a template, and we'll say tell me something about um, tell me about tell me a joke about, and we'll give it a topic, right? So this can be a good variable that we can have the user input fulfill, right? So open router underscore chain is equal to prompt LLM, right? So I'm defining a method, and I'm defining a LCEL chain, lang chain, expression language chain. If you have not read about it, I'll suggest you watch a video about it. Next, I'm going to say print. And again, if you, let's say, don't want to use paid models on open router, you can maybe come in, create a key for yourself, and get started with all the free models, right? The way I showed free models. You that way you won't need to load up. Let's say if you are a student, you don't want to use any of this. Maybe these are all the free models, right? Hugging Face FIR7B is free. So you can use all of these models for free, right? And this is a free model, right? Google Gemma 29B, and I'll just show you as well that we won't be charged any key for it, like any credits for it. So print, I'm going to call the chain, and I'm going to run invoke by calling, let's say, uh, we'll have to pass a dictionary here. So I'll pass in topic, that's what we have named it, and the topic is programming, right? So I'm going to pass in topic programming, and let's just see what happens, right? So something is not right, incomplete, print dot invoke, maybe, okay, I missed one extra bracket. Yeah, so I'm going to make use of the chat open router. It's probably making a call, none type object is not iterable, open router underscore chain prompt LLM. So what happened, something is not right. Open router underscore chain dot invoke. Okay, let me just again do this. Let's see if it gives me anything about banana. None type object. Why is it none type? Because I'm actually calling the chain. Maybe what I've done is I've just quickly changed the model, and now let's just see if this thing works. Maybe there was a problem with the, because we don't have any, the thing is, I don't have any try catch here. So probably the open router chain had some issues, in the sense when it invoked the LLM was not there, right? So um, why was the programmer assisted? Because he downloaded a virus, right? So that's the result we have got. So now we know that our connections are all right. I took another free model, Quen, and if you go back to now my usage, right? So if I go back to my usage and you look at it, Quen 27B, I was not charged anything for this, right? So there was nothing charged. And it even shows that the provider who's the provider. I don't see a call to Google Gemma, so maybe the model was down, right? Something was wrong with the model. Uh, OpenRouter also has this very interesting fallback mechanism, which I'll probably discuss in a while now, right? So I'll try to discuss that in a while. Now let me show you what happens. I'll just copy all of this, and we'll change this to flavor of the week. So like I discussed, flavor of the week is like, it's the same endpoint, but the model will keep rotating. And this is mostly a paid model. That's what my experience has been. Um, so let's just run this and see what result comes back. Why did the programmer? Because he wanted to debug his life, right? So 17 tokens. Here we had 12 tokens. And here now you can see that if I go back to my credits and my activity, you can see I was charged a like really low price for that call, right? So it went to Llama 3 Stenos. That's what the model is. And this is the provider, right? So if you go to the model, you can also see who are the various providers who are providing it. There are models that are provided by various guys, various providers. And what OpenRouter does is, if a model is provided by various providers and there is a downtime that some provider is facing, then it kind of does a load balancing and falls back to another provider, right? So it also has provider level fallbacks, and it also has model level fallbacks, right? So we'll see all of that. So now what we'll do is, our connections are all set up. Now let's get to this part, right? So I'm going to have a prompt, go to open router, and then go to three different models, right? And then we'll print the statistics about those models. So for this, what I'm going to do is, I'll first start by doing all the imports again. So I'll say import time, because I want to log the time. I'm going to import uh, tick token, because I want to count the number of tokens. Now, counting the tokens, I'll tell you when we come to that, can be slightly wrong in our case, but you will get it how to actually count the tokens, right? So, I'm not showing you the right way of counting tokens. I'm just showing you how to count tokens, right? So there are ways by which you can actually. There's slightly one more way, one more step that I'm skipping in the interest of time, but I'll let you know what that step is, so that if you want, you can actually go out and do that, right? So models to compare. Let's make a list of models. I'll say, hey, my first model is, and you should actually just come here and start copying, right? So we said we are going to do what? OpenAI, Mythomax, Claude, right? So I'm going to do that. OpenAI, Mythomax, and Claude. Um OpenAI, GPT-4 or Mini. I'm going to use this. So let's make a call to it. Look at the cost, right? 15 cents. Look at the GPT-4o cost. Um, $5, right? So look at the difference this cost is going to have on all the endpoints, right? And the amount of money developers are going to save. GPT-4o Mini. Next, Mythomax. So make a call to Mythomax. Greif Mythomax 13B Nitro. Okay, Greif 1213B Nitro. I'm going to make a call to this. Uh, Next, I'm going to make a call to Anthropic Sonnet. So we'll make a call to Sonnet. We can even make a call to Opus, Claude Opus. Sonnet. Opus is also there. Opus is a fairly expensive one, $15. Um I'm not making a call to this. I'll make a call to Sonnet, but the process is the same, right? So let's bring in a sample query. Again, the query is, I'm bringing in some query around quantum entanglement from quantum physics. Uh, Next, we'll write a function to estimate token count, right? So I'm just going to speed up the video a little bit, so that in the interest of time. So what I've done is, I have written a function called estimate tokens. It takes a text, and we are going to estimate the tokens out of this, right? So we rely on an encoding, and each model has a different encoding, right? So here I'm making use of class 100K base, and you can see model encoding CL 100K base. You will see, if you go to how to count tokens, if you dig further down, you will realize that each model has a different encoding class, right? So you have to basically give which model you are going to use, their encoding. Now tick token was built by OpenAI, so it largely supports OpenAI models. uh, but this is the way, if you get the model encoding, you can put that, because this is the way the tokens, the text is going to get broken. This is the algorithm. Look at it this way, this is the encoding algorithm which will break the large text into tokens, right? So, and therefore you will see that your token counts might not exactly match the token counts that OpenRouter will show, right? So we have the tick token estimate token count is there. Now let's build a method which will do call to the models, right? So I'm going to do that. We'll build a def around query models. um, yeah. So what I've done is, this is the query model, and this collab notebook will be available to you, so you can go through all the code. Right now let's just put a place our attention on understanding what is happening. So chat open router, it's a model name is going to be given from one of the list. We are going to loop through the list, so each time a new model is going to be given, we'll start the counter. Then we're going to say, hey, response is, we're going to make a call to the LLM, that the human message and whatever is the content, right? So the query we have already fixed. For all the models, we are fixing the query. Our latency is end time minus start time, and the content is response dot content, right? So if you look here, right, when we initially made the call, if you look at all of this was the joke, but it was within the variable called content, right? So I'm now taking that variable and printing only that variable. So the content is response dot content. Then we are estimating the input tokens and the output tokens. But the catch here is that the encoding class is fixed. It's CL 100K base. Now the model, not all of these models will follow the same class, right? So that is the part that you need to understand. Next, I have a JSON which basically has the name of the model and what is their cost, right? So GPT-4o mini takes 15 cents for input and 60 cents for output. Like, look at it. 4o mini, if you look at it, it takes 15 cents and 60 cents. And that's what I have encoded here as a tuple, right? So the first parameter is input and the second is output. Greif has 10 cents, 10 cents, $3, $0. And if there is nothing, then we are going to put zero, right? So we are going to take zero, zero. Like, we are going to assume probably you're using a free model, right? And we are going to then take the total cost, which is input tokens into input cost plus output tokens into output cost, divided by 1 million, right? So because look at it, this cost is for a million tokens, not for like each token. And then we are going to return whatever we computed so far. So this becomes my method. Next is, we'll actually make a call to the models, right? So we'll query each model and we'll display the results. So let's write that code now quickly. um, so this becomes my code for that, right? So I'm saying, hey, there is a results dictionary, and for each model in models, we'll first print querying whatever is the model that we are querying. We'll say result is a query model. I'm going to call this method called query model. And then whatever output we get, we are going to append it to the results dictionary list of dictionaries that we just had, right? So this is a dictionary I'm getting back. I'm basically just return adding that to the list, right? Then we are finished querying. If there is a problem, we'll report that. We are going to wait for 1 second, and then we are finally going to report result, list all the results that we get back, right? So let's now quickly run this code. And the collab notebook is part of the description of the YouTube video. Have a look at it. It says querying OpenAI GPT-4o mini, finished querying Greif. Okay, now that's also finished. Now it's querying Anthropic. um, and I think that's also should get finished now. And you can see there is slightly higher latency now with Anthropic. Okay, so now I'm seeing OpenAI GPT-4o mini, 13 tokens, 231 tokens. The total cost was 00141. Took 3.95 seconds, right? Quantum entanglement is a fascinating phenomena that occurs. And we are basically truncating it. I can truncate it at 200 also. We were truncating it at 100 because we're not interested in the response. My objective right now is to just show you how to think about these problems, right? 1.34 second, there was no cost, it says, for Nitro, because maybe I had Nitro here. or probably the cost is so low it doesn't matter, right? So we'll go to the keys, activity, and see Mitro 000492, right? uh, but you get it, right? So and also just look at it, maybe my thing was not right. This is charging 0.2 0.2, right? Provider, if the provider is fireworks, if they are charging 20 cents. If the provider is together, they are charging 27 cents, right? So so you see latency is similar, but they are like two different providers. um, and here, when I was building building the tuple, I had Mythomax 1213B, but in the model, I have a nitro added, right? So maybe if I remove the nitro, our model will start showing some count. Then Anthropic took a lot of time, took 8.1 seconds, and is the most expensive, right? So this also gives you a sense of what kind of models to use, how to effectively reduce your total cost, right? So maybe Mythomax or any other free model, right? Like let's just say we have Phi, which is a free model. Um, why not use that, right? So no, Phi is not free. Let's just see. Maybe this was a larger model. I'll go to prompt pricing, make this free. Yeah, 128K is free. So why not use this model, right? So I'll probably add this model as well to the list and see how it goes, right? So I'll just say, hey, make a call to this model. So what I've done is I've added, I'll add instruct as well to the models list, and we'll make a call to that, and let's just see what comes back, right? So same thing, just that this time there are four models, right? So I have Microsoft 5 mini instruct free, which is a free model. And one thought experiment for you is just go through all of these models, pick the free ones, and see for your kind of job, like maybe it's just a sentiment identification job you are running. Maybe it's just a job where you want to see, hey, go through this article and tell me, does it contain anything about AI? Like, is it relevant for AI developers, right? One project I'm doing right now, for which I'll make a video very soon, is we are going to read through a RSS feed and see if the RSS feed has anything interesting around for AI developers. Now, if I have a free model available, I would rather use that, like, just for identifying, right? This is more like classification. I'm not asking it to generate too much of content. Just go through it, and tell me, is it relevant for AI developers or not, right? Things like that, right? So Microsoft 5.3 took only 2.01 seconds, gave a pretty decent article, I feel, decent response. And if you go back here and go to my activity, you will see 5.3, I was not charged anything, right? So you have these kind of beautiful models available on OpenRouter. I hope you liked it. A lot of people have been asking me to make videos that make use of free models. Now this is one way you can use free models. I highly encourage. I really liked it. I discovered it very, very recently, and I've been playing with it since then, right? So, and I'm going to show some more projects in upcoming days on how you can use these free models to do simple classification tasks, right? So things like that. I hope you learned something new, something interesting. Again, what I'll also suggest is try out some fallback methods, right? Like, in case if this is not available, go to OpenRouter AI fallback code, something like that, the OpenRouter schema. uh, you might have to go through a little bit. There is a lot of fallback stuff available here. And, like, you can also list models, which models you would like to try in order. Let's say if OpenAI GPT-4 is not available, it will fall back to this. Most of these GPT-4 is usually going to be available, but let's just say if you have free models, right, like we were facing with Gemma. If you have a free model, you can have some sort of a fallback also available for you, and it will be very, very useful, I feel. So this was it, guys. I hope you learned something new, something interesting. I'm going to share this Google Colab notebook right away as part of the description, and I hope you really learned something new. And if you did, all I ask for is that you just like my video, subscribe, comment. That gives me motivation and also gives me hints on what kind of videos you really want to watch. Thank you.